Alright, so I wanted to take a video just so I could see what I was doing after the fact. Is the spot welder rig that I set up. Two 6-volt batteries, 9 amp hours each. That can deliver a maximum of 125 amps for 5 seconds each. So I put these in parallel. So I'm hoping to get enough current out of this to be able to spot weld nickel strips, 0.15 millimeter nickel strips onto some 18650 batteries. These are some cheap ultrafires that I bought so that I can practice. These are on eBay. They're super cheap. They're super shitty. They're nowhere near the 9800. Let's see if this even comes across here. No, 9800 milliamp hours. That's rated. They're closer to 1137. What else do I have here? 1234. You know, I just did some tests. So, this is supposed to be a 14.4 volt battery for an old NiCad tool that I want to upgrade to lithium ion. I have some BMSs that I'll put in later, but today I just want to see how well this spot welder operates. It is not at all, in any sense, safe. These wires get very hot after a few welds, so these need to be upgraded. I want to do something about this so that not everything is exposed. The relay is powered by this switch. The relay is activated by the switch, powered by the same battery, so I kind of want to fix that as well, but this is just a test to see that it works. I spot welded one of the old NiCad batteries that came out of a tool, and seems to be doing well. Yeah, so I kind of want to see what it's going to look like when I do the lithium ions. Now, there's going to be sparks. I'm working on a table that's metal. Super smart of me. And I just sort of want to make sure that this thing works and I don't die. Although, yeah, this could, you know, 250 amps could probably do a little bit of damage. This is probably not a good idea. Anyway, here we go. So, this is going to be the negative of the battery. This will be the positive of the battery. So we're going to go from here to here, then from here to here, then from here to here. And I don't know if this is coming across in the video because this is an old camera that I'm recording this on. So I've got my little ammeter here, clamp meter, that's going to tell me how much current is being pulled from the battery on a weld. So here goes. This is too long, I think. It's okay, I'll cut it later. What I'll do is I'll just do this point here first. Oh, probably should power the thing. Motherfucker. Okay. Where's the switch? Here. Alright, let's put this down here. Let's get a nice... They're not touching. Let's get a nice touch here. And I'm just going to look at the... Whoops. Fantastic. Let's clean this up a little. This is super DIY, and like I said, probably not the best idea. Okay. You got 40 amps out of that one. That's probably not too good. This is probably going to be a cold weld. Let's see. Let's do another one here. Didn't read that. 36 amps. These are warming up already. That's what it looks like. 2 little welds. A little bit warm to the touch, not too bad. And if I tug at this, it's actually on. So, you know, that's not bad. That's not bad at all. I think maybe this thing isn't working that well. Or maybe it just can't, maybe this can't read, it's missing the peak. Because I'm thinking we're probably pulling close to 200. We're shorting the battery, essentially, is what we're doing. Ah! Fuck. Yeah, blew right through it. Shit. That's what I'm worried about. There we go. Let's do it again. Let me just read the voltage across this one cell that I put together. Where's my voltmeter? There it is. This is, let's put it on 9 volts. Which ones did I fuse? These two. Yep, 7.7. Alright. Let's try and finish this off. So these two here, I'll probably end up cutting this bit off later. So now we're going to weld these two. Let's see how that goes. Hopefully I don't get sparks like I did again. What I'll do is I'll put this sort of over here. Get this on here. Get a nice contact. I don't think I have one. No, I did. Okay. And we'll do another one. I'm gonna have to figure out a way to get this thing so that it's, you know, not just this. Why am I gonna have to figure out a better harness for this? Like, this is getting really warm. Probably not gonna be able to do all 4 cells into one battery. Yeah, no, that's getting kind of warm. Okay, interesting. So I'm gonna need thicker. These are what are they called? Romex. Like stuff that comes out of your wall. So I might have to get something better than this. What was hot? Why did I... Oh, it's cooled down a lot since last time. There's a lot of heat coming out of the bottom. Oh yeah. A lot of heat coming out of the bottom here. Okay. Alright. Can do a couple more welds, I think, before this thing has to go on a break. And I believe I'm just going to disconnect this. I'm going to have to get these a little bit closer because these are button top cells. The cells here have button tops, as you can see them. Again, these are cheap. I'm upgrading an old tool that I don't really care about. This is more just me learning how to muck around with these batteries. So these batteries cost like $1 per on eBay. So I don't know. They're not going to work really well. I'm not going to get much use out of the tool. But again, this is just something to try. The better batteries, I bought a bunch of these Samsungs. They're significantly more expensive. I wouldn't buy these again just for the sake of it, because these are $10 per. They're Samsung. I don't know if you can make the writing out here. They're 3.7 volt, 3600 milliamp hour batteries, and I did test this. I tested all of them, but this one had 3616. So actually, yeah, this one's got a fair amount of capacity. These are good for. I actually don't remember. I think these are 10C batteries, so they can do something like 30 amps or something like that. Discharge. I'm going to be upgrading some laptop batteries. I'm doing the vice versa here, what people mostly do. People find old laptop batteries, pull out the 18650s, which I have done, and I've built some just shitty battery packs with them just to, like, nothing serious here. Like, these aren't used to do anything but power LEDs and whatnot. But I'm actually taking these and putting them in, replacing the 18650 cells in existing laptop batteries. So I don't want to muck around with a $10 battery. So I'm going to play around with a $1 battery first and see what I can do out of it. The nice thing about actually just replacing laptop cells is that you don't have to worry about BMSs and whatnot, like battery management systems, because those are already built in. In this case, when I replace the tool, the battery in the tool, I will have to worry about the BMS, which I have a few over here. Got some little ones. These are 4S, meaning they can take 4 cells in series. This is a 5S. It's a little bit bigger because I believe this can do 100 amps. This is probably when I'm going to upgrade some of the tools I want to keep with. Sorry, this is what I'm going to use to upgrade the tools that I want to keep. And then I have another one here, which is 40 amps, also a 4S, I think. I don't know where I'm going to use these. I just sort of went on a buying spree. So, in any case, let's get back to this thing. Plug the relay back in. Let's get a good connection here. Hopefully we don't get any sparks. Good, we didn't. And let's do another one. Okay. It's significantly warmer, although, it's not hard to touch or anything, but wow. This thing must be wrong. There's no way we're pulling 25 amps. Like, this thing's heating up significantly. Is this hot? No, these are like room temp. Can't even feel a difference. Okay, well, last battery here. So what do I want to do? I said this is the negative, this is the positive, so it's these two that are going in. Going in next, I mean to say. It's probably very hard to see what I'm doing on camera, but the whole point of this is to sort of just walk myself through this later. I might just throw this up on YouTube for, you guys. See what the hell I've been up to these days. There's not a solid connection that's going to spark. So. And good. And actually, I'm going to keep a better eye out on the readout of the ammeter. Yeah, absolutely nothing. You saw some smoke come out there just because I wanted to keep it for longer. And now these are significantly warm to actually they're hot. I don't want to touch this anymore. So I'm going to have to wait a bit more before I do the next, holy smokes, before I do the next, the last weld here. The battery is not warm to the touch. I mean, I should say it is warm to the touch. It's not hot at all. One of the main reasons why I'm not soldering these on is because apparently you're not supposed to. These batteries don't like the heat very much, and my soldering iron is, I don't know if it even comes out in the video, this is a few years old. It's, I think it's only like a 40 watt, so you have to hold it on to the end of the battery for a significant amount of time for it to heat up. So, and when I've done these before on some other batteries, well, it's gotten quite hot, and it's not, something that I wouldn't want to hold for a long period of time. So I figured, okay, I might as well go and try and figure out the spot welder thing. So while this thing is cooling down, I'll explain the spot welder a bit. A lot of people online just use car batteries. I didn't want to go out and get like an 800 amp car battery because that just scares the shit out of me. So I just went to Sci Electronics. I had originally bought one of these, one 6-volt cell, because it could do 125 amps, and I said, you know what, I'll give it a shot. So I welded on, I soldered on some brass tabs onto the plus and minus leads, and then I just drilled a hole for the solenoid, and then there's a connection from the positive end of the solenoid just coming right down to a tip here. Negative end going back to the negative end of the battery. Again, tips right here. So essentially what you're doing is shorting the battery when you hit the switch. The solenoid itself is powered through the same battery, so I got the plus going through on here. I don't really want to muck around with this because there's a lot of like exposed connections, and I'm not too I don't feel confident enough to move this thing around while everything's plugged in. And then the negative, of course, is going back to the negative end, and then just a switch. So you press the switch, activates the solenoid, so this gets power from here, and then you get basically arcing over here, but I've got something in between, and it just spots weld any two pieces of metal that are there. It works quite well, actually, surprisingly enough. This whole thing, each of these batteries is $25 each. This brass bar was a longer bar, maybe about 30 centimeters long. I just cut it down, and I got a couple of pieces left over from when I just had the one battery last time, so I had this soldered on like this before. So $25 each, $50. This thing was $10 on Amazon. These are from Sial. This thing was from Sial. Switch was from Sial. $50-$60. Which is fine for me because I'm really not going to be doing that much battery welding. You know, if I were to do more, I'd just buy a spot welder. You know, they range in the, I guess, $100 to $200 range. You probably don't want the $100 ones. Yeah. Alright, it's cool. Cool to the touch. Let's give this a go. Let's find a good connection here. And one more. Uh-oh. The biggest problem with this is these button tops don't have much surface area to clamp onto. This is probably going to arc. It didn't. So that read 40 amps. No frickin' way. No frickin' way this is 40 amps. So again, I'll wait for this to cool down. Significantly warm to the touch again. I mean significantly. I don't know. A lot warmer down here than up here. Noticeably warm to the touch. I don't know. It's nowhere near as hot as the time when I did 3 welds in a row. So the welds, yeah, no, they're on pretty good. I'm actually pretty happy with that. Let's read the voltage on this thing. Okay, let's disconnect this thing first. That's it. This is I'm just going to put it on 20 DC volts. Yeah, 15.8 volts. Next steps, now that I have these on here, I don't feel too bad about soldering on the BMS leads. And so the way the BMS works is, here, let me take one of these out. Take the small one out. Just toss this in the garbage. Alright, so let me look into the camera so you can see what I'm seeing. This is I have no idea if the words are coming right. 4S18650, so 4 series 18650 cells. The way it works is it has and what I might do is just sort of annotate the video. There's an overall battery minus battery plus, so the full 3.7 times 4 volts, and then you basically connect each of your batteries to these pads. So and then you've got the power. Let me read this. Sorry, what does it say? Oh yeah, these are the power. These are the power pads. So this goes to whatever device it is that you're powering, and then each of these is to your batteries. So your battery plus your first battery, second battery, third battery, fourth battery. You connect them to the negatives. or however you might want to do it. Actually, I have to read up on this chip to see how this one works. I've soldered one on before, but I've totally forgotten what it looks like. So basically, you just pull leads to each of these batteries, and the way this works is that when you charge it, it makes sure that it doesn't overcharge each specific cell in this pack, so that you don't get, these have a maximum voltage of 4.2 volts. You want to stop before then, but you don't want them going over 4.2 volts. These devices help with that. Now, this is a very small device, probably won't be that great, but these bigger ones, like this one here, actually, this will probably do a pretty damn good job of it. All right, it's got some, like, a lot of like bigger resistors and transformers here. It can do a better job. This is I got this, actually, I don't know how much this was, maybe $5 from either AliExpress or Banggood. I bought this one off of Amazon just because I wanted it here quick. It's a lot smaller, but it's $12 from Amazon. I just needed it and didn't want to wait 2 months. So, although I could have, because I didn't end up using it. So yeah, buy things like this off of Banggood or AliExpress, not Amazon, because they're damn expensive on Amazon. Actually, you actually can't even find this on Amazon. Yeah, that's it. I'm quite happy with this, actually. So I'm gonna go look at this video and sort of see what I did wrong, outside of what I already know that I did wrong. Fucking around with this shit here. And I'll probably post this and send it out to you guys, just because I think this is cool. Alright, bye.